Welcome further maths students. In this video we're going to go through some examples of performing a squared transformation, and this is covering exercise 5b of our textbook. So let's get stuck into the example. We've been given a set of data where we have some x values and some y values, and the first part of the question says to use your calculator to construct a scatter plot of x versus y and draw a rough sketch. So we're going to do this in the statistics screen. Clear whatever else might already be in there. And the x values, the explanatory values, we will always put into list 1. And the response variable values, the y, will always go into list 2. And to get our scatter plot, once the data's in there, we can go set graph and then setting. We want a scatter plot. X list is list 1, Y list is list 2. So all these settings are fine. We can hit set, tap our graph button, and we get a picture of our scatter plot. Now this question was just asking for a rough sketch, so I'm just going to copy and paste this in. And then we're being asked to explain or judge whether this relationship between X and Y is linear. And I would say that if we look carefully at the scatter plot, there does appear to be a little bit of a curve to it, right? It sort of seems to increase, the points are increasing quickly at the start, but then that's flattening off. So I would say that this is not linear because there appears to be a curve in the scatter plot. Smaller, get that to fit more nicely. Okay, part B of the question. It is decided that a y-squared transformation will be applied to linearize the data, so to hopefully make that scatter plot look a little bit straighter. Apply this transformation using your calculator and fill in the third column of the table above. So what we're going to do in our calculator, coming back into the statistics screen, is use list 3 to transform the y values, to transform the values that are in list 2. And we're going to use the cell at the bottom of list 3 to do it all at once. Okay, so our aim here is to square all of these y values. And we can do that by bringing up our keyboard and typing in, and you do have to go to ABC on your keyboard, and typing in the word list. And we want to tell the calculator, take list 2 and square all of those numbers. In other words, raise them to the power of 2. When you hit execute on that, a bunch of values should appear in list 3, and they do. So these are our transformed values. These are our y-squared values, and you'll notice that they are just the y values all squared. In fact, you could have probably done this without your calculator, but it's good to know how to do this for larger sets of data. So that's part B taken care of. Part C, use your CAS to construct a new scatter plot of x versus y squared and sketch this below. So we're going to go back to our calculator. We're going to create another scatter plot, but this time with our transformed variable. Now it's the y variable that we changed, so that becomes list 3, and we hit set. And when we sketch our graph again, we should get a different looking scatter plot, hopefully. Okay, again, we're just doing rough sketches to try to work out whether we have a more linear looking relationship. That down there, and certainly that scatter plot does seem to be relatively linearized, right? The relationship between the variables seems to be linear because those points are forming much more of a straight line. All right, so yes, we've got a linear relationship now as the points seem to form a straight line. Okay, determine the least squares regression equation for your transformed data and round the values of the coefficients to 2 decimal places. So here, like we're used to get the regression line equation, when we go back to our statistics screen, we use calc, regression, and then linear reg. But because we want the regression line after the transformation, we are going to change, again, y list to list 3 because we're doing regression between x and y squared. Okay, There's no need to copy the residuals as we don't have to do a residual plot here, but if we did have to copy the residuals, we would copy them into list 4. Okay, so here's our equation, and the calculator has given the equation as y equals a plus bx, but we need to make sure that we give our answer in the correct form. So we know that we performed a y squared transformation, so really our equation is y squared equals a is negative 1.46 if we go to 2 decimal places. B is 0.52 when it's rounded to 2 decimal places, times x. Okay, so that would be the equation. So notice the calculator doesn't know that we've done y squared, it's just giving it as y equals a plus bx, but we need to make sure we write down the equation with the transformation in it. And finally, part E of the question says to use the equation to predict the value of x where predict the value of y when x equals 8. So this involves taking our equation, substituting x equals 8, and figuring out what y is supposed to equal. We'll do that in our main screen. And we're going to type in, I guess what we're solving is y squared equals negative 1.46 plus 0.52 times 8, because we're letting x equal 8. And to do this, we're actually going to use the solve feature, right? So because we don't have y on its own, we're trying to work out y and it's squared at the moment. Easiest thing to do, use solve and put the equation in. We're going to solve it for y. Now you do have to tell your calculator to solve for y by putting comma y at the end, otherwise it'll look for x and tell you that there's no solution. It's giving us two different answers, and that's because when you solve for a variable that's being squared, you'll always get a positive and negative answer. In this case, given where our values are on the scatter plot, they're all positive x and y values. We're only going to be looking at the positive value, which is 1.643. And so our answer is y equals 1.643. It says to go to 4 significant figures, so the 3 is the 4th significant figure along. Next numbers are 1, so we round it down, and our answer is 1.643. If there was anything in that video that maybe you weren't able to keep up with, then rewind and go back and have a second look.